Domain and range of a function. So we see that functions are machines in which one input has exactly one output. So in a machine, in a function machine, so if you the input, if you write all possible inputs, if you combine all possible inputs and write them in a set, this set has a name. It is called the domain of the function. In other words, we can say that inputs we denote with axis. So we denote our input with the x. So you can say all x values that you can input so that we get an output is the domain of the function. Similarly, if you write down all outputs in a set, it is called the range of the function. So we denote our outputs with y variable. We can also say all y values. If you write them in a set, this is called the y values are the range of the function. So if you combine all x values, that is the domain, and all y values or all possible outputs, that is the range of the function. So we may or may not have restrictions for the domain. Same thing, we may or may not have restrictions for the range. In other words, we can say that sometimes we can input anything in the machine, but sometimes input anything in the machine means we can input anything in the machine and we get a valid output. But sometimes we may have some restriction for the input set. Restriction means if you input something in the function, we may not get any output. So that means that input is not a valid input. We should not include that input in this possible input set, because that input is not giving us a valid output. So let's talk about some restrictions. Suppose we have a soda machine. Soda machine, we input something in the soda machine and we get an output. So this is a function, right? So this is an input output machine. So can we input anything in the soda machine and we get an output? No. If you input pen or pencil in the soda machine, we don't get any valid output. So pen or pencil is not a valid input for the soda machine. So that means pen or pencil does not belongs to the domain of the soda machine. So what will be the domain of the soda machine? So all those inputs which will give you a valid output. For example, coins, cards, bills. So these are the all possible inputs for the soda machine that will give you a valid output. So this will belongs to the domain of this machine or this function. Same thing, we may have some restriction for the output set. We may not get everything from a soda machine. So if you think you cannot get pizza, burger as an output from the soda machine, we have a restriction for the soda machine. Suppose the soda machine has only one type of soda, the Coke. The output will only just Coke. So that is the range of this machine. So we may or may not have restriction for the domain and range. So let's now see that. Find the domain and range of this function. If a function is given like this, suppose this is a function whose elements are suppose this is a function. So one input has one output, one has one, two has a. If you want to graph this as an arrow diagram, you can say this is a function f. Input is 1, a 1, 2, 3, and output is just a. So draw an arrow going out from 1, 2 and 3 towards A. So one input has one output. We don't have two arrows going out from any input, so this is a function. And what is the domain of this function? Domain of this function is 1, 2 and 3, and the range of this function is A only. Okay, so let's talk about function notations. Function notations algebraically. So we have learned about equations for like y is equal to 2x plus 3. This is a mathematical equation. So in functions, we use the mathematical notations, the mathematical equations, but we change y with fx, just the notation. We just say y is equal to fx. This is when you use fx instead of y in the mathematical equation, this is called a function notation. Let's now take this example. Let's use this example. Suppose fx is equal to 2x plus 3. So how this machine is working? So let's read it. So we are inputting input x in this machine. So f is a machine. We input x in this machine, and our output is 2x plus 3. So this is our y, that is an output. So how this machine is working? We input something in the machine. This machine is multiply the input with 2 and add 3 in the answer and give you the solution. So you can input, if you input 1 this in this machine. So how this machine is working? Multiply the input with 2, add 3 and give you the solution. So 5 is the output. If you input 2 in this machine, so what is the output? It will multiply 2 with the input, add 3, give you the output 7. In other words, we can say that, so f of 1, if you input 1 in this machine, the output is 2 times 1 plus 3, that is 5. If you input 2 in this machine, we will get 2 times 2 plus 3 is equal to 7. So here, when you write down the function in general, we are given that when you input x in this function, this is the output. Now you can replace everywhere the x with different numbers that we are given. If we want f of 1, we will say that it is 2 times 1 plus 3. We just replace x with 1. Similarly, if we want to evaluate f of 2, we replace x with 2 on the left hand side, do the exact same thing on the right hand side. If we want to find f of 7, just replace x with 7. This will be 14 plus 3, that is equal to 17. So how we will read this? We will say that when we input 7 in this function, output is 17, or f of 7 is 17. There are different ways to read this. 7 input, 17 output. In other words, we can say that image of 7 under f, image of 7 under the function f is 17. F evaluated at 7 is 17. So there are different ways to write the same thing. So what we are actually doing, we are calculating the output when you input different values in this function. And how this function or this machine is defined? This machine is defined like this. So we can evaluate our function at different values of x. So let's talk about this example. Suppose fx is equal to 1 over x. So let's evaluate this function at different x values. So this is the x value and this is f of x. When you input x value 1, the output is, you can say, replace x with 1, that is 1. When you input 2, the output for this function is f of 2 is 1 over 2. When you input 3, the output is 1 over 3. When we input 0, what is f of 0? Replace x with 0, that is 1 over 0, that is undefined. In mathematics, if the denominator is 0, that is undefined. So we didn't get any output. When you input 0, we didn't get any output. When you input minus 1, the output is 1 over minus 1. That is minus 1. When you input minus 2, the output is 1 over minus 2. So you see that. So can you write down the domain of this function? So domain is all x values that will give you a valid output. You can say that if you input positive values, you get an output. If you input some negative values, you still get an output. But when you input 0, there is no output. We get undefined. So that means you will say you can input all real numbers. So R stands for all reals minus 0. You cannot input 0 in this function because how this function is defined, if you input 0, we don't get a valid output. In other words, you can say minus infinite to 0 and 0 to infinite. 0 is not included. We have an open bracket towards 0. So either this way or this way to write down the domain of this function. You see that we may not always input everything in the function. So we may have some restrictions. Thank you so much.